All right, hi, I'm Bea Schleupner, and I'm a senior studying biology.
I'm Ella. I'm a junior studying biomedical engineering and biology, and we're part of the Vast Connections team called Bioremediation of Plastic Pollution to Conserve Marine Biodiversity.
All right, so raise your hand if you're concerned about plastic pollution. Well, I'm glad you're concerned because plastic production continues to grow and humans rely heavily on plastic for daily needs. Now, commercially, plastic is a very versatile product, but we aren't sure how it actually affects our health. What we do know is that the average American consumes and inhales up to 121,000 plastic particles every single year. And that number only increases with bottled water consumption. We also know that plastic has been discovered in the human lungs, the colon, the intestines, the blood, and even the human placenta. So to tackle this plastic problem, our BAST team consists of 3 subteams. The first team is the Plastic Additives and Human Health team, which investigates whether plastic itself is dangerous to our bodies. Then we have the Bioinformatics team, which is searching for new enzymes that can degrade plastic. And then finally, we have the Bioremediation team, which is trying to create a highly efficient strain of plastic degrading bacteria in the lab. So clearly plastic is everywhere, but does it pose a risk to us? That's what the health portion of our team is set out to determine. What's in plastic and does it harm our own bodies? And what we determined is that we actually don't know much about what's in plastic. We did a literature review and found 2,700 chemicals that are used in plastic for various functions. Of those 2,700 chemicals, 2,400, or about 90%, were completely untested in the World Health Organization cancer database. That means we only had cancer data on 10% of those chemicals. And we found similar rates of unknowns in the EPA database run by the United States. So what we learned from this is we need to do 2 things to tackle the plastic problem. First, we need to do more research on the chemicals in plastic to see if it harms human organs. And second, we need to find ways to reduce the amount of plastic in our environment so we don't ingest it at such massive rates.
This is where our bioinformatics team comes in. Because of the prevalence of plastic pollution in the natural environment, hundreds of microorganisms have already evolved the ability to degrade plastic. Our bioinformatics team asked the question, what do these plastic degrading organisms have in common? And we found that the enzymes these plastic degraders produce share common sequences and structures. As you can see in this image on the right, many plastic degrading enzymes share this very similar 3D protein structure. We then asked the question, what other microorganisms produce enzymes with the same sequence and structure and could possibly be plastic degraders as well? And we identified a bacterium called Pseudomonas ditzeri, which could be a potential plastic degrader. And we're now testing in the lab whether this strain can actually degrade plastic. Lastly, our bioremediation team is seeking to use directed evolution to improve the plastic degrading function of a bacterium called Ideonella saphiensis. So this bacterium has been shown in several previous studies to degrade plastic, but it isn't effective enough in its natural form to be used in large-scale bioremediation efforts. Using a technique called error-prone PCR, we introduced random mutations into the plastic degrading enzyme that Ideonella produces, and we've generated a library of more than 200,000 mutant enzymes. Using this genetic diversity, our next step is to use natural selection to select for any mutants with an enhanced ability to degrade plastic. And in this way, we hope to generate a highly efficient plastic degrading microbe. In the long term, we hope to use these plastic degrading organisms in a solar powered bioreactor. So imagine one day being able to throw your plastic waste into a bioreactor and converting that waste into recyclable byproducts, instead of that plastic ending up in the ocean or the landfill. In conclusion, these 3 subteams come together with 2 main goals. First, we hope to identify the effects of plastic exposure on human health. And second, we hope to identify and further develop plastic degrading microorganisms to tackle this plastic pandemic that we face today. We'd like to acknowledge our teammates and our mentors for their dedication to this project, and we thank Vast Connections for this opportunity to share our work with you. Thanks.